In this model, we're going to look at a push versus a pull system in an office environment. So here we've got the person at the green workstation. He generates documents at half a second per document, and then it takes 10 seconds to travel. Now we show him going on a little conveyor here. That could be an electronic transmittal time as well as a physical move. And the documents go over to the man in blue, who takes 1.25 seconds per document to do the step that he needs to do. So these documents could be physical folders like they're shown in the animation, or they could be electronic versions of the same. So we're going to do a push system where he has a batch of 100 of these he's going to be doing, and as he's doing them, he's going to accidentally make a mistake, and he's going to point to a old version of the database after 30 documents, and he doesn't realize he did it, so he'll start producing documents that are bad. So they're going to show as bad, but they're not going to realize it until the blue workstation discovers it. So let's go ahead and run this and see what it looks like. So here are my controls. So he's producing the documents, half a second each. And the next workstation is processing them. Now they're queuing up because he processes it slower than they're sending them. Now at this point, notice he started, I'm going to pause it, he started producing documents that have the error in them, except he doesn't realize it, so they're just going to be stacking up and stacking up, and he's just producing more of them. So let's see how long it takes and how many they make until they realize that he's pointing to their old version of the database and he's filling in incorrect data. Okay, so here it comes. And there it is. So they did about 70 bad documents, and it took about 33 seconds for them to find them. So not a very good situation. Now let's see what happens if we were to do this as a pull system. So in this view, we're going to do everything exactly the same. The only difference is we're going to add Kanbans. Now the Kanbans could be a physical card that's actually with the document, or it could be any way of electronically keeping track of these same numbers. So let's go ahead and run this one. And what we're going to do is we're going to have 10 Kanbans in this system. So what you'll notice what happened was we got 10 Kanbans. So he produced 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then he used all the Kanbans, which are represented by the Ks here on top of the documents. And so once he had no more Kanbans, he stopped producing. So the production status went to red, and he's no longer producing. He cannot produce until he gets another Kanban recycled back to him. And the Kanbans, the documents are going to hold the Kanban while they're in transit, while they're in queue, and while they're being processed. Okay, so he's still not producing because he didn't get the Kanban yet. Okay, so the blue workstation finished the document. He took the Kanban off, so he released the document with no Kanban, and the Kanban went back to the green station, and he was able to produce. And so he made one real quick, and is already waiting for the next one. And as we run this, you'll see now that the pace that he's producing is really controlled by how fast the blue station can handle them, not how fast he can produce them. The distance between them now is based on that time of the second workstation. If you look at the chart, I'm going to pause it. If you look at the chart, you'll see the red line represents what happened in the push scenario, the scenario number 1. And in this scenario, we have not yet produced a bad one because we're not producing them as quickly. Now there goes the first bad one. And so you can see now we're making bad ones on the second scenario here. Let's see how long it takes to find that. Okay, so there they found it. So it took 12 seconds to find it in the second scenario, whereas it took 33.8 seconds to find it in the first scenario. So instead of producing about 70 of these, we produced about 10. So a big, huge improvement. Because basically we were overproducing and ignoring the problem that we had. So let's think about what else we could do. And the other thing we could do is we could try reducing this transit time. So whether physically move them together closer or make it so our machine can more quickly transmit it electronically. Let's see what impact that could have. If I do that, I can reduce the number of Kanbans now. Let's say we only need 4. And I've done a little bit of trial and error to get that number. Let's go ahead and run this and see what this looks like now. We don't need as many Kanbans because there's not so many sitting on this conveyor. So now the first scenario is already producing bad ones. By the way, when he detects the mistake, he'll tell the green machine. Let me pause it. When he does detect the mistake, he'll tell the green machine, and let's assume the green machine instantly can point to the correct database with no delay, just to keep things simple. And by the way, I can speed this up if I want to. Okay, so you see, now we've got only 4.5 seconds until we detected the first bad one. And it looks like we only made about 4 bad ones total. Maybe 5 in there somewhere. It looks like 4. So a much, much better system for controlling it. So by reducing the number of Kanbans that we needed, we were even able to fine-tune it even more. So with that, I open it up for discussion. And think about what else could we do. Could we go and do a root cause analysis to determine why the error was made to begin with? If you Google things about why there's errors in documents, pointing to the wrong database is a very common error. How can we mistake-proof that to make sure that he always gets the right one? And one thing to note is that the Toyota Kanban rules say a Kanban item should all be good before they're going on. So we need to make a way so that we don't allow the bad documents on the Kanbans. With that, I hope you enjoyed looking at the model, and I hope you see how Kanbans can be very helpful in an office environment for a pull system.